Okay, we're still recording, so just be mindful of that. Today we're going to talk about frames and events. So let's just take stock of where we are. So we're week 9. So next week is going to be, what is it called? I call it reading week, but it's called SWAT-VAC, or what is it? SWAT-VAC. Okay, so next week you have some type of break week, which in America is called reading week. And the idea is that you're supposed to catch up on all of your work. So I'm going to take note if anyone comes back with a tan. So no teaching activities next week, no lectures, no tutorials, and the prac won't be open, or the help center won't be open, mainly because your assignment's due Friday. So there's like nothing really to help with. I hope that's going okay. I hope most of you started it. It's due in a handful of days, so please do it. In terms of integrity, so like I ended up writing up maybe like 10 people, so you should have had an email from me by now. So I just encourage you again, if you're like panicking on Thursday, don't cheat, because like we're gonna catch you. It's a lot of paperwork. It's no one wants to participate in this write-up procedure. I also have a very serious question to ask the class, an allegation to the class as a whole, and I want you to be honest with me. Are you making me do Uno because it's currently TikTok viral? Okay, good. Because you asked me to do, because you know how we're doing this game and it's going to be Uno. I go home and like Uno's all over like my Instagram through TikTok. So there is some celebrity YouTube soccer match. You didn't see this? YouTube soccer match. Uno. This. No, this is the 9th, right? So anyways, the instant you ask me to do Uno, like Uno becomes like a meme on the internet. So I thought this was a little bit suspicious. And I thought those two things may have to do with one another. So if you tricked me into doing something that's cool on TikTok, shame on you, class. Shame on you. Okay. So frames and widgets. So we've just been sort of studying the TK interlibrary, which is a bunch of web gadgets, which are pre-built objects that allow us to create windowed applications effectively. Now, last week we were just talking about how to place sort of text in these type of windows, and the placement was done relatively through this stacking or packing. We also learned how to do things like style and like how to name a color using its hexadecimal triplet. So today we're just going to add so one extra widget, which is a grouping widget. It doesn't really do anything, but it's a widget which allows you to put stuff inside of it. And this is called the frame. And then you can move the frame around. And this is going to give us a lot more flexibility when actually designing layout. And then the second thing we're going to talk about is events. Now, event-driven programming is hard. Like, it's one of the reasons we don't normally introduce GUI programming in an intro course. What we've been doing up till now is like called deterministic. Like, if I gave you a program and I said, what does this output? And you were able to just go down it and not make any mistakes evaluating the Python output, you should be able to compute the output of that program, no problem. And someone else would be able to compute it and should get the same answer. Now, with events, this is kind of different because we're going to write functions which are kind of going to be like print hello world when it's raining outside, something like that. And like that's not deterministic because like we don't know when it's raining outside. So this notion of triggering functions, not when we call them, but when something in the real world happens, like a phone ringing or someone pressing a button, this changes the game a little bit because it changes a deterministic type of setting to non-deterministic or probabilistic type of setting. So adding probability into the scheme always makes things a little bit more complicated. And if you really want to get into the technical nitty-gritty, then properties about the operating system and how the scheduler works are going to be really relevant. But None of that should be relevant to us. This should be more or less easy peasy. Okay, so let's talk about frames. So a frame is just another widget, and that widget is used to sort of put other stuff in. So last week I just created a root window and then put everything in the root window. But that's not what we do really. What we do really is we create a root window and then we put frames in our root window and then we put widgets into those frames. So let's just take a look. Well, let's just code this. All right, so let's see how much you remember. So from tk inter import tk, I want to get a root object. So that's just a tk object. I need to main loop it or nothing's going to happen. I also need to like set some type of geometry for this. Why aren't I getting auto completing? That may be bad. Geometry 200 by 200. Let's say 400 by 200. Okay, so what kind of box is this going to give me? Wider than it is high or higher than it is wide? Wider than it is high. Whoops, I knew something couldn't have been. Cannot import. Oh, geez. Import tk inter as tk. That's better. Now I'll get my auto completing. Right, so this is a window that's 400 pixels wide by 200 pixels tall. So that's width by height. Is this going to work? No. All right. So because this is on your exam, it's submitted. It's like 100%. This question is on your exam, and the answer is something like 400 by 2. You just have to remember that it's width by height, no spacing. Okay. So here we go. We have one window. It's a tk inter window. It's 400 by 200. Now we can put stuff in it. All right. Well, let's put a frame in it. So I'm saying we have a frame. This is a tk.frame. Maybe I'll give this some background color. Let's say pink. And then we're going to put the frame into the root window. So that goes here. And then we have to pack it. And I'll just let it expand. tk.true. Okay. Nothing. So like it's there, but we can't really see it. I know I gave it a background pink, but it would need to be filled in order for us to see it. So this is not overly useful yet. Let's try to put a couple buttons into here, or labels. So let's have Alice. She can be a label. We're going to pack it into frame. We're going to have, what is it? Tag? I always forget the options. Where are the slides? Oh, here. It is text. I was right. Okay, so this is going to be Alice. And let's maybe say it's black. Okay, and then we can just pack Alice. Let's do one more. Let's have a Bob. So here's Bob. He's also a label. I'm going to pack Bob. Foreground black. Let's give these some background colors. That's maybe red. This one's maybe blue. All right, let's see what we got. Okay, so here's Alice and here's Bob, my beau, right? In a frame, right? You can see a little bit of the pink background there of like the frame that it's living in. And because I told this frame to expand, that's small house, big property, right? So this frame is living in the middle. And it has all of this space around it. So let's just play with the packing. All right, so I'm going to change this back to Bob. And let's pack from the left instead. This one too. All right, so now we should see Alice on the left and Bob on the right. There we go, something like that. It's in a frame. But let's instead of expanding, I'm going to show you what happens if I start changing this. Okay, so I'm saying, here's the frame. I'm going to pack the frame to the top. And do you see how Alice and Bob came to the top? Because although Alice and Bob are stacked left to right in the frame, I can move the frame that they're in around this window, right? So if I say something like side dot left, right? Now they're on the left. If I say side dot bottom, should be the same thing. Okay. And so this is because this green frame is effectively what we've put the labels Bob and Alice in. Right. And this is going to allow us to move groups of widgets around instead of individual widgets. And in addition to that, it's going to allow us to draw things that we wouldn't have been able to draw last week. For instance, no one's been able to prove me wrong yet, but I don't think this is possible to draw without frames. So if we just limited ourselves to packing from last week, do you think we could use packing to get a number pad like this? Like, tell me the side order to pack. I don't think it's possible. I'd be happy to be shown wrong, but how could we do this with frames then? How many frames do you think we should use to do something like this? Yeah. 4. What are the 4? 1 for each row. That seems pretty sensible. I'm going to say 5 because I want to put the whole thing in like a number. So I want to do that. Okay. I want to have a frame where my number pad lives. And then I want to have frames for each row. Okay. And then I want to put labels in the row frames. So let's investigate this. Outside in. So I have a green frame. Okay, so let's just spin that up. Okay, so let's maybe do 300 by 300 here. We want a square. Everything else I'll get rid of. Okay, so we need like a number frame. I'm not really supposed to use Polish notation or what Hungarian notation. Polish notation is something different. Okay, so but for now I'll use it. So this is a number frame. It's going to be a tk.frame. It's going to live in the root window. And then it needs to be packed. Okay, number frame dot pack. And since it's the main one, I'm just going to let it expand. True. Okay. So that's the green one. Or actually, yeah, I'll leave it as a number frame. So what we need to do now is create 4 row frames. And then in one of those row frames, I want to put 3 buttons. So how do the row frames stack in the green frame, like the number frame? Top, right? Because it's like this row, then that row, then that row, then that row. How do the labels stack inside each frame? Left to right. Okay, so the numbers have to be packed side equal left, and the frames, the row frames have to be packed from the top. Okay, so let's just do 1 row. Okay, 1 row. So we have to do something like I want a label. That's going to be a tk.label. Into this label, where do I want to put it? Well, I want to put it into the row, a row frame, which I just realized I don't have. Okay, so we need a row frame. That row frame is going to be a tk.frame, and I want to put this in the number frame. And we already agreed that this has to be packed from the top, the row frames. This is the default setting, but let's include it anyways. Actually, let me just recover some vertical space. That should be fine. Okay, so we have a number frame which is packed in the root. We have a row frame which is packed in our number frame, and then we want a label to be packed into our row frame with text. I think the first one is going to be equal to 0. Let's give it some width just so it looks nice, and maybe some padding. Right, pad x equals 5, pad y equals 5, and then let's take this label and let's pack it to the left. Okay, let's see what we get. Whoops, yes, I want to save. No, I don't want you to disappear, but where are you, sandbox? Okay. Maybe I will give this some background color, red. And I'll say foreground color equals black. There's 0, maybe 2, that was too wide, maybe. Cool. And then if I want 2 more, we can do this, but I want to discuss this afterwards. Okay, so here's 0, here's 1, here's 2. Red, blue, green. Okay, let's just see if we got a row. Cool. Is this good? How much code have I duplicated? A lot. Should I like copy paste this 7 more times? No. What should I do instead? Pardon me? I think that's the most. So my colleague over there said make a class. Yes, I think that's the most correct answer. But what I'm going to say is, why don't we just more generically use Python? Like, this is what I want to remind everyone when we're GUI programming. Don't forget you're actually in a programming language. You don't have to code everything like you would HTML, right? Like some people revert to how they used to do web page design. In particular, how much do these labels differ by one another? Or what do they differ by? Yeah. Oh yeah, we're going to use loops and if statements and all that nice stuff. But these labels, what is the only way that they differ? The number in the background. Okay, so why don't I make a function and that function can return a number label? All right, so this thing's going to return a tk.label. It's going to take, let's take a number. It takes an integer. And it's just going to return this label. Okay. So I'm going to return that label. We'll worry about the color in a second. Just let me tap this out. Okay, I'm going to return that label. And instead of having that text there, I'm going to say this is the string version of X. So this whole thing can now just be replaced with number label or 0. Right. And this could be replaced with number label for 1. And this can be replaced with number label for 2. And let's just take a look at what's happening here. Okay, 0, 1, and 2. Way cleaner. Okay. I have a fun little thing. Where is it? Here. Okay, so just remember that a color is just a random, a color is just a triplet, right, of numbers between 0 and 255. In particular, it's a hexadecimal triplet. And here's a fun piece of code that just generates a random hexadecimal triplet. So in effect, it's generating a random color. You don't have to understand how this works. It's not too hard though. Like, here's a function that returns a random number uniformly between 0 and 255. I'm asking to do it 3 times, and this is just converting from base 10 to hexadecimal. But in effect, I just get a random color. So instead of having this thing here, I'm just going to put random color. And then we should. Okay, cool. Like now all the backgrounds are different. I don't have to specify one. Okay, so that's how I get one row. We can be a little bit cleaner as well, because like this could have been in a loop. So how can we now get this? We want to do this for 0 through 9, right? So let's just, okay, so I want to look at every number in the range of 10. Okay. So how many rows do we need? 4. Where did they start? Well, this row, the first thing is 0. This row, the first thing is 3. This row, the first thing is 6. This row, the first thing is 9. What's common between 0, 3, 6, and 9? They're all divisible by 3. Okay, so that means that if k is divisible by 3, right? Start new row. Yeah? So let's do that. How can I test if k is divisible by 3? Yes, k mod 3 is equal to 0. Except we don't write that in Python. We write this. And so I'll just leave that as a comment. We never do a zero test in Python. It's just not done. It's not the done thing. Right. So we would never say if X is equal to 0. We would say if not X and exploit the truthiness. But that is kind of confusing. I acknowledge it. So on your exam, like if you ever see something like this, you should immediately write in that to the right on the paper. I do, right? Because this makes a lot more sense to me. Okay, how do we start a new row? Well, we got that. So I'll just put there. I'll put that there. And then I need to put some numbers in. But that's easy because I have a function that does that. So I'll just put K in there. Okay, so there's a little piece of code. So do you think this will give us our number pad? Let's cross our fingers. Ta-da! Okay, so first lesson is use Python when designing your GUIs, right? We want to use things like loops and functions to do stuff. Because suppose I wanted to change my styling of these buttons, like I want more padding. Okay. I just had to make that change in one place and it propagated to all of the labels. Whereas if we did it manually, and I do actually have that, just so you can take a look, like this is how it looks. Right. These are equivalent pieces of code, right? And this one is, even if I were to clean it up and use a function, it still looks quite long, right? So we have to be clever when doing these things. So that's more or less how frames work. We're going to use frames to help arrange our widgets. And in particular, we can put frames in frames, right? This is sort of a recursive type of thing. Events. Okay, so events are the thing I said is going to be the spanner that we're throwing into the machine. That is to say, it's going to make things a little bit more difficult. It makes it especially difficult to do testing on your code because these events are random and they usually involve humans, and humans are pesky, non-deterministic type of agents. So what kind of events are we talking about for tkinter? Well, a button press. Like, can you tell me when someone is going to press a button? No. Text entry, any input from the user is always going to be non-deterministic. Key press, which is different than text entry. Text entry is type a bunch of stuff and hit enter, and then I'll grab that. Key press is like I'm detecting every time you press a button on the keyboard and reacting to it. And then mouse click in movement, right? These are all the sort of events that we're going to want to capture with a computer, right? Because a computer has a mouse and a computer has a keyboard, and sort of these are the comprehensive events that a keyboard and mouse can trigger. There's some new terminology that I have to use. So when an event triggers, we handle that event, right? And when an event is handled, we invoke a function called its handler. Okay, so event is some non-deterministic or random thing that can occur. To handle that event is to react to that event and do something. And we're handling that event with something called an event handler. So the first widget we're going to look at is a button. Here's an example of a button. So a button is a widget or web gadget that you can click. It can register clicks as an event. So let's just create a really simple, let's create a widget with a button in it. So I'm going to get rid of most of this stuff again. I do want to keep my main window. Okay, so here we have empty box again. Okay, I'm going to put a button in it. So here's a button. It's a tk.button. I already forget what I'm supposed to put in here. No, it's always text. Okay, so I'm going to put it in the root window. Don't press me, bro. And then we need to give it a command, which is going to be the handler. So we'll come back to this. I'm just going to put in foo. Well, okay, we'll come back to that line. Okay, so then I need to take the button and I need to pack it. And let's just let it expand. So it's in the middle of the window, tk.true. Okay, so there's two things we can discuss here. So here's my button. I can press it. It doesn't do anything. Notice that it's the button is the smallest button it is, and it has like the most amount of space around it. This is what happened when we expanded. If I go down here now and also fill, what this is going to do is it's going to give us the biggest button that it can, like the whole thing now is a button. Right? So this is a good way of understanding the difference between fill and expand, right? The whole little house, big yard, or big yard, big house type of thing. Okay, so I don't want to fill. Okay, so it's not really that useful to have a button that doesn't do anything. So naturally, what we want to be able to do is do something in the event that this button is pressed, right? That's the button is triggered in effect. And that's what I'm saying this is for, right? So the command is the thing that is invoked when the button is pressed, right? So when the button is pressed, we're going to handle that event by executing or calling foo. So I'm going to go up here. I'm just going to write a simple function called foo. It's just going to print debug, okay? Or actually, I think ouch is more appropriate in this case. So let's see what happens here. Okay. So if I press this, this should run, okay? See? And this may seem menial, but it's kind of like, well, this button is going to execute a function. That function can be as arbitrarily sophisticated as you want. I'm not saying that it's always going to just print a debug message. I'm saying it's going to do something, right? So when I show you that this button can print something, you need to think, oh, this button can actually execute an arbitrary number of Python commands, which means you can get it to do whatever you want. Okay, so when I press this button, this command is going to call that. Some funny things that we can investigate here. I'll show you. Okay, so this will change the line indenting of the print so that it doesn't hit a new line. So like things won't appear each line. And like here's funny stuff now that happens with the scheduler. I'm pressing. What's happening? Why isn't stuff printing? Well, it's because the operating system is scheduling these button presses, and it's like, you haven't hit return yet. Like there's nothing, I don't know how much text you yet want me to print. So I'm just going to sort of like hang around and wait till you're finished. If I close this, watch what happens. Because that was waiting in an output buffer, waiting to write to the screen. So I don't know if you've ever experienced this. Maybe computers are too fast, but have you ever been typing on your computer when it's like really strained? And like nothing's showing up on the screen, and then it waits a second, and then everything shows up, right? This is why the like events sort of make things a little bit tricky, because like how closely should the computer be waiting and reacting to button presses? Should it be like should that be the highest priority of the computer to take input from you? I don't think so. Probably the highest priority stuff on your computer should be displaying to the screen, right? If it stops doing that, you think the computer is frozen. Right? Doesn't look like it's happening. So there's a whole other operating systems course that computer scientists and engineers are going to have to take, where you're going to have to consider this type of stuff, right? The computer is not actually able to do things simultaneously. The computer is able to do one thing at a time. And it just happens to be cycling between all of the tasks that it's supposed to do so quickly that the operation of the computer actually is like, seems fluid. But it's fluid the same way that animation is fluid, right? That if I flash at you a discrete set of images, it looks like it's movement, but it's actually a set of discrete pictures, right? So that's just a little side event or about how the operating system does stuff. So let's not worry about that, but there is a parallel I want to show you. What do you suppose that will do? Isn't this weird? I called the function without rounded braces. Don't we normally call functions, invoke them with rounded braces? So what happens if I do this? Well, what does it mean to put rounded braces at a function? I'm calling the function. What does the function return? Nothing. What have I put into command? Nothing. So what? Okay, so if I run this program, what is its behavior? Button clicks, nothing happens, but something will happen before that. It will print ouch once, right? And it will print ouch once because foo was called. I'm saying call foo, and it's like, okay, print ouch, return none. Right? But like now nothing else is happening. Okay. And this is called the silent failure because Python's not actually telling you that anything is wrong. Because to Python, nothing is wrong. It's like, if you want me to handle this button press by invoking none, you got it. Right? But you got to be careful. If you include those braces there, which is a common mistake because we're just sort of used to putting them there, your program won't run correctly, and you won't be notified that it's not running correctly, like at least outside of our grade scope type of testing. So that doesn't come there. Although it is possible to have functions return functions, which we haven't talked about yet, but this shouldn't be sort of, I don't know, like we had a function return a label, right? How come we can't have a function return a function, right? So, okay, let's do that. So I'm just going to create a function called bar. Then I'm going to define this function foo, and it's going to return the function foo. Right now, I can do this, right? Because what's the invocation of bar doing? I'm saying bar execute, and bar goes, okay, I'm going to return to you this function. So command now gets that function. So if I run this, right now we're back as normal, right? Because functions can return functions. So this is a little bit nuanced, right? But we called bar because it returned a function. Now if I did this, whoops, oh no. Who knows Unix here? Anyone? So this was a command that took this and overwrote what I had in bar with the contents of what this is. I deleted something by accident. So is life. So every time I hit this button, it's nothing's going to happen. It's going to create a new function and put it there. And so we have to be very careful with this, right? So I'm just going to remove that. I don't need this. We'll go back to that, and this can go back to being foo. Okay, so now we just have our ouch, ouch, ouch. Okay, next one. What do we got next? So that was our first event-driven program. Having a button that does nothing is pointless, all right? So we have to put something in this command called the event handler. All right, and so again, notice the absence of the brackets here. That's important. The next widget, text entry. So I said we were going to draw a distinction between reading text and detecting button presses. So this one is like if you want the user to type their password or type a message or something like that. So we want to create some type of TK widget that looks like this. Over here is like a text entry widget, and then here's a button. So what I want to do is create a program where I can type something in here, and if I hit this button, I want it to show up in my debug console in my bash. So let's give this a go. I just hope that I remember all of the optional parameters. It's always a trick, always tricky. Okay, so what do we want? Okay, because I need the button, I'm going to keep it. Let's just make this like more wide and see what we get. So we have a button. I need a text entry widget. So text is going to be tk dot. What is it called? Entry. Okay, it's going to be an entry widget. I want to pack this into root. I think that's enough. And then I'm going to pack this, and let's pack from the left. Did I give it a background color? Yeah, okay. Maybe background equals blue, something like that. Okay, we have our button, we have a command, we have a text entry widget, they're packed. Let's also say that the text entry widget gets to expand. And let's say this is packing from the left as well. Okay, let's see what we got. Cool. Okay, we got a window. We have our text entry. That's not very visible. Maybe I'll change that to something. And then we have our button, which is now only executing ouch. Okay. Let's change this to, is light blue an option? Let's see. No. How about this? Ah, perfect. Okay, so this is a little bit more readable. Okay, so what I want to do now is somehow use, there is the get method here to echo what is in the text entry widget to the screen, right? So I'm saying if we could do something like text.get here, right, it would print what's in the text window, but I actually want to do that here. But what's the problem? So this foo needs access to text. So I'm going to be a little bit cheeky and just do this. Like, I'm just going to give it access to it by saying, okay, use the global widget. But like, I always say using globals is bad, right? Like, this is bad. And I'm only doing it because I'm like presenting to you in class and trying to keep things simple. What's the solution to not using global variables when working with GUIs? You already gave me the answer. Yeah, we're supposed to be doing all this stuff in classes. And we will. We're gonna write a calculator at the end of the class. We'll do it properly, right? So that will solve the scoping issue. But for the time being, I'm just gonna use globals to be a little bit cheeky. Okay, so I should be able to type in here. And then I should be able to press this, and it should show up in the bash. Okay? Or we can do Taylor Swift instead. There, Taylor Swift lyric generator. Okay, but the point is that this text entry gadget or widget had a get method, which is like retrieving the contents of the text, right? So these widgets are like sort of allowed to utilize the state of the window itself, right? I can always change this too. Okay, so because I said that we can have functions return functions, I can actually do something a little bit clever and get rid of this global. Okay, so I'm going to do this instead. I'm going to say def bar. So this is going to be a function that returns a function. I'm going to say bar, you actually should accept some TK entry as input, and then we'll set it up, right? So I can now say this, right? The command is bar when I give it text, because I'm saying, hey, bar, here's a text entry gadget. I want you to create a function foo, which has access to it, and just prints that text.get, right? So this is going to solve the scoping issue. Or I lied. Did I not save? I need to return this. It won't like that. I need to return foo. Yes, because before that I had none. Okay, so let's try this. Aha, right? So I actually managed to like get rid of that scoping issue by no longer using globals. You may see this being done in A3 quite a bit, right? Because buttons are going to require handlers, and a lot of those handlers are going to look the same. So we don't want to write unique handlers for each of them. I want to write functions which write the handlers for me, right? So we got to sort of get used to the fact that a function can return a function. This is actually one of the higher level language features of Python. It's not normally, so there's something in programming languages that are called first-class objects. And a first-class object is anything that you can pass to a function or can be returned from a function without like hacking away at the system, right? So integers are first-class objects. Of course, we can take numbers and return numbers, lists, right? But it's not usually the case that functions are first-class objects. It takes some finagling in C to have a function accept a function, for example. In Python, no problem. Functions can accept functions, functions can return functions. Python doesn't care, right? Because a function is just another object in some sense. And so that it is one of the nicer language features. Oh, this is a fun one. Okay, so one of the most important events that we can track is that of a mouse click, right? This is why we started using GUIs, right? It'd be pointless to only have GUIs where we'd have to type on the keyboard. That wasn't really why they were introduced. They were introduced because of this nice new input device called the mouse. So how can we now react to mouse clicks and mouse movements? A little bit more sophisticated, because the mouse is a little bit more sophisticated. So what we're going to do is spin up something called a canvas and put that in our window. The operating system isn't going to let us know where the mouse is at any given time. That's too much information. Operating system is a little bit secretive. It says you can spin up a canvas and you can know when the mouse is within your canvas. Okay, so let's just do that. So, okay, we're going to get rid of most of this stuff again. I don't need that. I need the, let's change this back to a 300 by 300. And we'll just spin up a canvas, right? So a canvas is a place where you can detect movement and draw. And this is where we built Fortnite last year. tk.canvas. Yes, this has to go into root. Let's give it a background color, maybe pink. I'll take canvas. I'm going to pack it. Maybe I'll let it expand. And we'll let it fill. All right, let's see what we got. Okay. This is a window. Inside is a canvas. It's expanded. It's filled because that's why we see this pink, but like does nothing at the moment. So what I'm interested in doing is trying to bind into this canvas. So this is a new term. So we bind Python functions and methods to an event triggered by a widget, right? So somehow this canvas, where did it go? Okay. The canvas is an object, and the canvas can detect that the mouse cursor is inside of it. So the canvas is going to say, basically shout, hey, there's mouse movement in me, right? To anyone who's sort of listening. And the people who are listening are the people who are bound or binded to the canvas, right? That's how we set up people who are waiting around for the canvas to scream information, right? So that's what this .bind operator is going to do. And I'm saying to this widget, I want to bind, okay, I guess I'll say with English then, okay. To this widget, I want to bind this event with this handler. Or in other words, to this widget, I want to set up someone to be listening for this event to happen. And in the case that this event happens, I want this handler to be triggered, right? So in the specific case, it's to the canvas, I want to bind something that is listening or waiting for mouse movement or mouse button presses inside the canvas. And when that happens, have this handler, which is a function, do something. So when an event occurs in the widget, the handler function is invoked with an event object describing that event. So that's going to be a little bit careful. There's a bind all for binding handlers to the entire application, but be careful with it. Okay, so what event do we want to do? I think probably motion. Okay, so here are some of the events that we can be listening for, right? We can listen. Listening's not really the right word, but it's a good, I don't know, like it's the right idea, right? But maybe listening is not overly correct. But these are some events that we can wait for or wait to handle. So like button presses, a specific button on the mouse being pressed, motion of the mouse in the canvas, motion in the canvas while a specific button is being held down, the release of a mouse button, the release of a specific mouse button, and the key being pressed on the keyboard. Right? These are all of like the basic building blocks of creating like a game, for example. Like in a game, we need to know the position of the mouse cursor. So let's try to do motion for the time being. Okay, so I have a canvas, it's packed, and now I need to do something weird, and I need to bind to it, and I need to bind the event that I want to wait for. It was motion, yeah? Motion, okay. So the other thing I want to mention is normally I use these angled brackets to designate something as optional inside, but no, like I literally, for these events, it's literally what you see here with those angled braces. These angled braces have to be included, okay? So I want to bind motion, and then let's give it a handler, foo. Okay, so I got to make an event handler called foo. Let's just print a debug message. Okay, and I'm saying, okay, so you know in your classes how every method has to take self, and self is a special sort of name. In tkinter, the event handler has to take the single command event, has to, right? This is how it is being invoked, right? When the canvas is like, yo, there's mouse movement in me. It's passing through this event object. We can be a little bit more clever with our debug message here because this event actually has a bunch of properties. For example, it knows its X position. and it knows its Y position. So let's just spin this up. Okay, cool. Okay, so see, okay, if my mouse goes into that canvas, that event handler should be triggered, which should print a message to my console. Agree? So I'm not in it, and let's see what happens. Ta-da. Okay. And because it's printing, that means you can like handle it, right? Like I don't say who cares that you could print these numbers. It's like, it's not the numbers that are printing that's the interesting thing. It's the fact that I'm reacting to movement in the canvas in the first place. Like this foo can be a function of arbitrary sophistication, right? Like move link could be what foo is doing, or like aim targeting reticule. There's something else I want to discuss here. Let's look at this top left corner if I can. What is the position of the top left corner? What? Well, oh, it's hidden. There, yeah, there is a 0, 0 in there. Okay. So because the event has to say, I am detecting motion inside of me, it has to report back positioning. I'm detecting motion at this position. And there are various number of ways that we can report that positioning back. So from math, we have the Cartesian coordinate system, right? How does that work? Well, you give me a square. I draw I designate the center of that square as 0, 0. And incrementing the x component moves me right, and incrementing the y component moves me up. Right? So if you have a Cartesian coordinate system and you want 3, 7, that's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay. In the coordinate system so it doesn't make sense to take your monitor and divide it up like that, if you think about it. What coordinate system makes more sense on a computer? Like what's the dimensions you really care about? Let's think about what computers used to be able to do only. And they used to only be able to do like text entry, which means what? Well, the relative positioning should be how many spaces have you hit, so that like how far away are you from the left side of this, and how down are you from the top of the screen? That's the positioning that makes sense on a computer. Okay, so the canvas actually has a coordinate system where the northwest extreme corner is 0, 0. Incrementing x moves you right, and incrementing y moves you down, which is the opposite of what we're sort of used to in the Cartesian coordinate system. But this coordinate system makes more sense on a computer, right? Because we're always typing, which moves us from left to right and from top to down. But it doesn't matter. You can always sort of convert the coordinate system if you want by writing functions. So here are some of the event objects attributes. We already saw them, right? So an event is an object that's being passed around. It has attributes. And we're allowed to access them like this because the system never sort of designated them as, or asked for them to be private. So we can get the x and y coordinate of a mouse. We can get, so okay, this is a little bit strange. So I want to detect key presses. So let's try an experiment. So look at your space bar, anyone who has a computer, and go 2 buttons out to the right of your space bar. Okay, my button is option. What's your button? Control? The point is we all have keyboards, right? And they all have the same symbols on them. And they're all like basically the same, but they're a little bit different, right? So I have option to 2 buttons away from my keyboard. Someone else has control. Okay, so how then do we standardize button presses if everyone's keyboards are kind of the same, but also a little bit different? Well, there's 3 ways that we can standardize this. The first way is by char, and that is tell me what is written on the key that you pressed. Right, there are characters written on them, so that's one thing that we can report back. If I hit the button with the L on it, you get an L. The second way we can do it is just to standardize create sort of like a tkinter bespoke Unicode table, right? And say, L, we're going to standardize the letter L by the number 7. And then you are responsible for telling me that when you hit L, that it's 7. So this is good in tkinter because we can be standardized with key presses in tkinter. And then we have this key code, which is like platform specific. So this would be sort of unified over all Windows machines or all Linux machines or all Apple computers. So it's typically this key sim that we use, and we'll investigate that a little bit further. It doesn't make that much of a difference. The point is, I don't want to write a program that says, oh, if the user hits the key 2 keys away from the spacebar, do this. I want to say if the user hits option, then do this. That's more universal. Okay, just more exercise. We're just doing a lot of programming today. Write a GUI that prints the coordinates of a mouse cursor whenever the cursor moves within the canvas. Oh, well, we did that. Too easy. Config. Okay, so what we've done so far is like created widgets and then given them styling and then packed them. Okay, well, like what happens if we want to change, like suppose we want to have a label and then change what that label is printing. Can we do that? Yeah, but we need to do it by way of this configure method, or like really what it is like a reconfiguring method. So if you gave, well, we'll just do this in the thing. Let's just get rid of this. I don't need that. Okay, let's have a label. So here's a label. It's tk.label. Let's put it in root. Let's give it some text. I am label. And let's pack it. Doesn't really matter how it's packed. It's just packed. And let's give it some background color, pink. Okay. Now I want to change that pink color somehow. But like, how do I do that given that like the label has already been created? Well, at any given time, I can say label.config and say, hey, change your background color to, I don't know, black. And that will make it, whoops, oh, black. Okay. So this will make more sense when we're like doing things interactively. So I think I have a, okay, here. Okay, so let's create a window with a button that when I press the button, it's going to toggle between purple and yellow, like a light switch almost, but the light switch is like just a single button. And this will be, this will demonstrate what we want to do. Okay, so first we need a frame, I suppose. We need a frame and we need a, so here's a frame. It's a tk.frame. We're going to put everything in it. This goes into root, and let's say this has a background color pink, or what was it, purple? And let's pack this. And let's just say expand equals tk.true, and fill equals tk.both, and we should have a window with purple in it. Perfect. Okay, next I want to put a button into the middle here. So let's just get a button. That's a tk.button. I want to put that into the frame. The button, I don't know, press me. And then we should pack this button. And then maybe I also let it expand. And that should give me a button in the middle. Cool. All right. Doesn't do anything because we need to give it a command. Okay. Button needs a command. That command's going to be foo. So what should foo do? Okay, so let's just print a debug message for the time being. Okay, so instead of printing debug, I want to change the color purple to yellow. So that shouldn't be too bad. So I'm going to be cheeky and say, give me access to that frame. Again, don't do this. And I can say frame.configure the background color to be yellow. Okay, so this means that where did it go? This means that if I press that button, this is going to be triggered, this handler, and the handler is going to change the frame color to yellow. What happens if I press again? Yeah, it's stuck in yellow. Okay, so how do we make a toggle back and forth? Pardon me? What does the if statement ask for? That's the $1 million question. How do I say if it's yellow? Yeah. Like a globalized variable. Okay, let me put this to you. The canvas is currently yellow, right? The information that this canvas is yellow surely exists somewhere. Yeah, we should, like, I'm not saying spinning up a variable is wrong. I'm saying spinning up a variable is redundant, right? Because this somewhere there has to be something saying I am yellow. Do we have any other answers? Pardon me? Yeah, but how do I get it? I don't expect any of you to know the answer. Like the real answer is like, yeah, we have to look like, I'm just trying to tell you how I think like a programmer. It's like, this is yellow. It's an object. It has to know that it's yellow. Therefore, I look in the docs to figure out where is this telling, like, where's the getter telling me that this is yellow? And let's try to use it. Now, did I put it? Okay, so we have to be a little bit cheeky here. Because I think a frame is technically a dictionary. So I can say something like, if frame at its background color is equal to purple, then do this, else do purple. And I think I guessed properly. Aha. Anyone have epilepsy? Ready for our party? Okay. Right. So these frames, like, so when you're working in these bespoke libraries, like you're going to have to do a lot of reading the manual. If you ever seen the acronym RTFM as a response to you asking a question, that's what it means. Read the manual with an extra word. Okay. This is what software engineering is about. And this is why we're like, write comments, write documentation, like make it so that other people can easily understand and use your code, or you're going to make other programmers irritated. The same way that we would be irritated if tkinter was really sparsely documented because we need to use it. Yes, sir. Pardon me? Can you config buttons? You can config any of the display attributes of any widget, right? So I could change like the button is, like the label on it, for example, or if it had background color. But I can't change a button into like a text entry widget, right? You can config the command, yeah. Yeah, if you wanted. I'm not saying this is the only way to solve this problem. Yeah, like the lesson was that, like, if this is yellow, something surely has that set as an attribute. We should be able to grab that. Okay, cool. We're going well. Okay, write a GUI that shows the 3 encodings corresponding to a key press, right? So the idea here is that I have a window, I've pressed F on my keyboard, and it's displaying me the thing that's written on the key, the TK interstandardization, and the operating system's encoding of that letter. So let's give this one a go. And then the last thing we'll do is like write a calculator application together. So I want to get rid of all of this. Okay, so back to just having a square. Okay, so now I need some type of frame. Fame, great movie, by the way. TK inter frame. This has to go in root. Let's give it some background colors. Pink. Let's let this expand. Oh, that's the frame. I don't care about. Oh, no, I do want the frame. But that is a packing operation. Expand equals true. TK dot true. And then I need to put a label in it. So here's my label. It's a TK dot label. I want this to go into the frame. I want this to have text equal to specific thing like this. Okay, so first I'll put in debug, and then we need to write a handler. Okay, debug. Let's label.pack. This can also be expanded. So let's just see if I have a box with a label in it. Okay. So now what I want to do is detect key presses, which is going to be like an event that's happening on the computer, which means I have to instruct this tkinter object to start listening for events to be triggered. So what was the command that we introduced for this? Starts with a B, ends with eind. It's bind, right? We need to bind to this window in order to listen for the key press event. So I'm going to say, okay, hey, frame, start listening for the event of a, now I have to go all the way back, key. Okay. For this key. And when that happens, call foo. And foo is an event handler, which takes event. And for now, we'll just print a debug message. Okay, so I think it's event. And we have, yeah, event char key sim and key code. Event char event key sim and event key code. Okay. So this should work. So I'm going to start hitting keys and we should start seeing stuff on my debug console. Not working. Was it? Maybe I need to bind to the label. Maybe I need to bind all. Okay, hold on. Key presses are always a little bit problematic. Aha, okay. So I bound to the top level window. Okay, so you see I'm hitting keys on my keyboard and we're getting that debug message down there in the console. But I don't want it down there in the console. I want it up here in my label. So we have to use a global variable to get access to the label. And I don't want to print this. We can still keep printing it. But what I want to do is take the label and reconfigure it so that its text is actually this. Okay, so here, and now if I start hitting buttons, there you go. Now we have like, it's now appearing in here, right? So like Shift S, it's saying that's the thing that you've typed was capital S. It's the tkinter standard representation is capital S, and the operating system unique identifier is that number. But see, I'm like detecting all of these presses, right? So WASD, right? You could move a little man around this canvas if you want. Okay. So this whole time I haven't been using objects, right? Because it sort of makes things overly complicated when I wanted to just focus on a single widget. But as I mentioned, we do not use global variables. So we should be using class and objects to design these GUIs. So this is sort of the loose framework that we use. So we're going to write a calculator app, and that app is going to be, and that calculator app is going to be a class. Now, what do we instantiate that class with? The rule is that the main tkinter object, the root object, has to be created by someone else, right? So I'm saying, I will make you a calculator, but you have to give me a tkinter window to put it in. So that's how this works, right? So I say, if I wanted to launch this app, I would say, create me a root window, a tkinter object, create my app by giving it that root window, and then main loop. Okay, so our object is going to do everything but create the initial root window. That has to be passed to us. What do we have in chat? Okay. So this is our objective for the remainder of class. Let's write a calculator application. Shouldn't be too bad, mainly because we did the number pad is like already. So let's discuss the overall design. How do you want to do this? How should our, okay, because I'm really going to start from scratch and design this whole calculator app. So what's our plan? How should the like overall organization of this app be like? What is one thing this app has to have? Pardon me? Who's speaking? Sorry, I'm not, oh, yes, go ahead. Yeah, it needs buttons. So we need to at least have buttons. That's a good start. What else does this calculator have? A screen, a display, right? So, okay, so let's think about the display. What is our display? How should we display stuff? What TK inter object do we have that displays text? Yes, why don't we make it a label? Okay, so the display is going to be a label with text in it. Okay, that solves that. Maybe we can put it in a frame, a display frame at the top. Okay, so at least this is like, how many regions should we break our calculator into in terms of its layout? Yeah, 3 seems sensible. There's a display, there's this like number pad, and then there's this like arithmetic pad. So why don't we start there? Let's create a window, let's break it into 3 pieces, and let's put a display on the top. All right, so again, blank canvas to calculator. Okay, so import TK inter as TK. Okay, now I need a if main. I think if what was it? Name equals main, then print. Let's just start here. So this is a special sort of command that says, hey, please run the following code if I call this function. So if I do sandbox, I should see print hello. Cool. Okay. So now what I need to do is create a calculator app. So that's a class for calculator, calculator. What does every class need? I'm inheriting from nothing. So what should my first method be? Good job. Yeah, we need an initializer. What should this initializer be taking? Yeah, the window to draw, like the main TK inter root window needs to be a argument here. So I'm going to say, give me the root window. Sometimes this is called master. That's a TK inter object. So this should be, okay, so now we need to create a root window out here. TK.TK inter object. We need to main loop it or nothing's going to happen. And then in between, I actually want to call this calculator app with root. Okay, so far nothing is happening. Let's just set this private. Let's give this some geometry. Set self.root.geometry. Let's just eyeball it. Okay, this is a little bit wider. I don't know, like 400 by 500. So 400 by 500. Let's see what this gives us. That's not right, because I did the thing width by height, not height by width. Okay. Maybe a little bit wider by 50, maybe a little bit shorter. Okay, that looks sensible. Now what do we need? We need the display. So let's get a display. I don't think we need to, well, okay, let's put it in a frame. Okay, so here's a frame. It's a TK, oh, it's a TK.frame. Let's put this into self.root. Let's take this frame, let's pack it to the top, even though that's the default. Because I want it to go all the way up. Let's actually just say, we give it some background color, light blue. And let's say that this can expand. Why not? TK.true. And it can fill TK.both. Oh, no, X. I want it to fill along the X. And then I want to put a label in it. So this is going to be our display, which is a label. And the label, I don't know, let's just start it with debug. At first, it has to go into the display frame. So maybe let's just call this display frame. There's me using Hungarian notation. I'm not supposed to. Okay, so we're going to put this in the display frame. It's going to have that text debug, and then I need to pack the display so that its side is to the left. Let's see what we got. Cool. I don't want that to be on the bottom, though. I want it to be at the top. So I guess I shouldn't have expanded. Okay, we have a display. Now what? We need the number pad, and we need the arithmetic pad. But let's think about, okay, so I'm going to have to create 16 buttons. Do I want to do that by scratch? No. How do I want to do it by? Yeah, let's write a method in this case. Okay, but like, what should the method take and what should it return? A symbol. I think that's a good idea. Yeah, like, so each of these buttons, because I was waiting for someone to say a digit, then I was going to say, well, what about plus and multiplication? So yeah, we want to create a button where given, okay, so let's just start there. I want to create a method, which I give it a symbol, and it returns to me a button, right? Ready to go. Okay, so there's our number pad. And let's just set up, okay, let's do it. Let's write something for button. So def make button self, a symbol, which is going to be a string, and then this is going to return a TK button. Cool. So we're going to return a TK.button. What's the button going to have? It's going to have some text. What's the text? Oh, is going to be symbol in this case. It has to pack into, yeah, we better make that an attribute, right? Because we don't know where yet we're packing these buttons. It's going to depend on the frame. So I'm also going to say, oh, tell me also where I am packing into. So I can say pack into, yeah, make a button with this symbol that's going to be put into this frame. Okay, so I'm going to return a TK inter button with that frame, with that text symbol. And let's just give it some styling. I'll say the width, let's say is 2, the X padding is 5, the Y padding. You usually want to put padding to make stuff look nice. And then since this is a button, it's going to need a command. I'm just going to call that foo. And we'll just have a debugger at the moment. We'll say, you know, print the symbol. So let's see what's, okay, so that doesn't, okay, let's just see we get no errors. Perfect. Now let's try to put one button in the number pad. Okay, so my number pad, that's going to be in the number pad frame, I suppose. tk.frame. I want the number pad frame to go into root, right? The big one. And then I want the number pad frame to pack from the left. Right? Because like display packs to the top, and then this giant frame should pack from the left, and then the arithmetic frame should pack to the left. So I have a number pad frame, and I got that. We're going to need, well, let's just put one button in that, and we'll be satisfied for the time being. So give me a button by calling myself with the make button routine. What symbol do we want? I don't know, 0. And I want you to go into the number pad frame. And then actually, we can just pack it straight away. Let's see what happens now. Okay, I have a button and it's echoing to the screen. That's a good start. Okay, but now I need to do this for like all 9 numbers. So let's use loops. Okay, so for k in range 10, like for every number between 0 and 9, if not k mod 3, that is to say, if k mod 3 is equal to 0, if k is divisible by 3, then I need a frame for the row. I'll call it row frame. These row frames are actually packing into the number pad frame. And I want to do the rows. Yeah, they pack from the top. Row frame pack from the top. back. We'll just have the default parameter. Okay, so then I need to put this into the row frame. And I need to do this once for every k. I should change that k to a string. Let's see what this gives us. Not what we want. Yeah, I need to be packing. Who sees my mistake? I know my mistake. How should the numbers be packing into the rows? Left to right. What are they packing now? Top. Why? Because I didn't put anything in and top is the default. Okay, so if I go here to back and I say side, go from the left. Aha. And what are these doing? Cool. Like they all are registering like the number that they've been hit. Let's see if I can't get that to go into the middle. I think I just have to tell the number pad that you can have as much room as you want. Cool. It's in the center because I have not yet put anything to its right. Yeah. Did you want to put 0 in the 0? I can change it if you want. Do you want me to change it? I think it literally requires, I just have to write like another line of code. Oops. No, you don't need to see that. How come I can't? Calculator. Oh yeah, they put their 0 down there. Okay, let's see. Let's see how easy I could change this if I wanted to change this. Because really, I just need to put a +1 there. And then mod by 10. Let's see. Huh? 10's not possible. Why is it putting a 10 there? Because it's +1 + 10. Oh, yes. Order of operations, kids. Remember them for your exam. I can forget because I only write the exam. I don't take it. Okay, sorted, right? But you see how I didn't like make like huge amounts of changes to my code to accommodate this? I'm like, wait, let's think. Cool. If I just add a +1 here, that's going to sort everything, right? So don't always rush to be changing everything, right? Because I feel like there could have been some changes where we started from 1 and then like created an edge case afterwards, but using math is more clever. Okay. And it's great because like the button doesn't care that we've made that change calling into it, right? Because it has this symbol. What should these buttons be doing? Like we don't want to echo to the bash, although it's nice to know that they're working. Like what should pressing 6 do? Yes, sir. Yeah, if I press a 6, it should show up in the display. Okay, how do I like make the display change? Well, the display is a label, and we can reconfigure the label if we want. So let's do that. So what should foo, when we press a button, what do we want to happen? Update. Okay. So I'm going to go up here. I'm going to create another private variable called display text, and we'll start that off as debug. Okay, so now this is like this. I can access the state of the display anywhere. And I'll just go ahead and put that here. Okay. So what should foo do? Right? Foo should change that, then flash the screen. Okay. So flashing the screen means to redraw the display label in case some change has been made. So, okay, I'll show you what that looks like. Okay, so if we want to flash, this is a standard piece of terminology. This is just a method that doesn't return anything or returns none. And what I want to do is take the self.display, I call it frame or is it just display? Just the display. I want to take the, oh, that should be private. Oh, I need this. I need the display frame. Okay, hold on. Change all occurrences. Self dot underscore. Okay, so now I have access to the display frame everywhere. Okay, so what's displaying in the text? I want to Oh, that doesn't happen here. I just want to change, okay, self.display frame dot configure. And I want to configure its text to be what's currently in self.display text. Right, I'm just saying reconfigure the label so that your text is the thing currently that we are like storing as the thing that you should be displaying. And here in foo, all I want to do is this. Okay, so I'll keep this debug message, but I'll just say go to self, change like to the display text, add this symbol to it, and then flash the screen, which is a method. So I actually have to invoke it. So let's see what happens here. Hooray, unknown option text. I knew I did. Oh, I did the frame. I don't need the frame. I need the label. Oh, what a bummer. Okay, hold on. Yeah, I did. I made a whoopsie. I don't need the frame.
I think what you need to check in your in the flash function.
Yeah, I need no, I need to grab this display. So this needs to be like this. Oh no, that's gonna destroy. Okay, I can't do this. I have to do it like this. Right, because I need access to that display. So I need to promote it to that scope. So display text, display frame. Whoops, no, that's still flash. I'm all configured. Flash, self.display frame. Display, not the frame, just display the label. Hopefully this will sort it. Okay, you see? That like the numbers are showing up in my display. Up there. Oh, wait, I can't point with my finger at the screen. Here, stuff showing up. It's cool, right? Because like we didn't, like the button didn't need that much work, right? In order to do all, like, could you imagine making 9 unique buttons that's accomplishing this, right? So we're being very clever in our use of methods. Suppose I want to add like the decimal there in the clear command here, which was part of my original one. How can I get those? I just sort of have to do a little bit of an override. But if we go here, we can be a little bit cheeky. I can say if k is 9, that's the last row that we're going to be processing. Just go ahead and make this bespoke button that contains a decimal. And then after you're finished everything, make another button with C in it. Okay, like now I can have like 8.9. I think it's time to get rid of this debug message and let things start from empty. Cool. So now I have like 5.93, right? Clear does nothing yet. Okay, so let's fix clear. What should clear do? Like, what is the purpose of hitting this clear button? Yeah, set the display, like revert it. Okay, so somehow, so here's a button. Okay, let's pack it. But now I want to reconfigure. Someone asked this question. So this is me reconfiguring a new handler. So this needs a new command. And what should the command do? Well, I don't know. It should clear self dot clear. And let's write that. So what does it mean to clear? And you see what I did here? It's like I sort of like this sort of like top-down programming. It's like, what do I want to put here? A clear command. Oh, okay, fine. Put in a clear command, and then we'll go write the clear command. Okay, so here's me writing the clear command, return none. I need to take I need to set the display text to nothing. And then I need to flash. So let's see, now we should have a clear button. Cool. All right. What's left? We need to do the arithmetic pad. Okay. So this is like one column effectively. So I need one frame here. I need to pack that frame from the left because that's where this number pad has been packed. And then I want to go top to bottom with plus, minus, multiplication, and equals. So let's give that a go. So I need a arithmetic pad frame. That's a TK inter frame into root. I want to pack that, to the left and let it expand as much as it wants. And then I need to put buttons in it. Okay, so how can we put buttons in this? What should I do? Well, should I like create 5 buttons manually? What tool do I have that I wrote? Yeah, I have a method that like given a symbol, like makes a button. So here we walk through numbers. Well, so what do we want to walk through here? Yeah, actually, I can do this if I want. Plus, minus, divide, multiply, equal. Equal special. So let's remove that. Okay. So for a symbol in those lists of symbols, more or less what we need is to get a button. So that's this. Put it in the arithmetic pad frame. And then pack from the top. Let's see what this gives us. All clears. Oh, because this needs to be symbol. Okay. Okay, cool. So we have our numbers. And look, because we were clever in the way that we created the make button, by saying that the only thing that it should do is take its symbol and put it into this display, this is already working, right? Those buttons. No changes necessary because we were clever by the way that we implemented these things. Okay, so what remains? I just actually want to look at this because remember how I was saying when we went from imperative style programming, which was a function pipeline, like X goes into F and Y comes out, we give Y to G, which Z comes out, we give Z to H. So with in imperative programming, we basically are doing function composition. And I said in object-oriented programming, we're going to create an object and we're going to do a series of method transformations on that object. And this is going to characterize object-oriented programming. That's what this is. You see? Object dot do this dot do that dot do this, right? Dot 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 method 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 method, right? Self dot make this dot pack this, right? So this is leading into the object-oriented approach, and we'll do this really severely in a second. Okay, so what is left now, I guess, is just to make the equal button. That should be equal. And we should also pack this to the top. Okay, but we need to reconfigure this button, like the equal button, to have a different handler. So what should its handler do? Well, let's just say it should evaluate. Evaluate. Okay. And we don't have that method, but it's again, it's aspirational. Like, so okay, I don't have it, but I can write it. Self-evaluate. Self. This returns none. Okay, so what does it mean to evaluate? That means take the expression that's in the display and evaluate it, and then replace the display with that evaluation. Okay, so there's a bunch of stuff that I need to show you. But it's like one of those things where I need to show you to do something, but you're not ever allowed to do it. And it's always like the sex education all over again. There is a command in Python, which you give it any Python instruction, and it can evaluate it from a string into a whatever its evaluation is. But this is true, like you can, this is any Python program that is put in here will be evaluated. Okay, so that is to say, eval is a command that is letting someone else run arbitrary Python commands on your computer or Python programs on your computer. This is like ludicrously unsafe for us to use this eval command. I'm just using it for the purposes of this calculator, but don't use it in your day-to-day. The appropriate thing to do would be to write a parser that says this is an arithmetic statement encapsulated in a string, and we can write write a program to evaluate it, but we'll use eval because it's easier. Okay, so what do I want to do? I need to evaluate what's in the display. Right, so that's what's in the display. This is what it evaluates to. This is turning it back into a string. Then I need to put it back into the display. And then I need to flash the screen. Okay, let's see what we got now. Oops. Oops. Okay. 6 plus 9 equals 15. Times 5 divided by 9.7. That's clear. Cool. Okay. But what have we not done yet? What should happen when I hit equals? Like, we're designing this. So I ask you as designers, what should happen when I hit equal here? Why did that work? That's bizarre. I wouldn't have expected that to work. Oh, no, because unary plus. So plus 3 is positive 3. Plus 3 is positive 3. So what I just wrote was like 1 plus positive 7. Okay, let's try something that's certainly not going to work. Times divide minus plus 3. That shouldn't work. I hit equal. I triggered an error. This is all broken now. Oh, I don't know why it's still running, but errors are bad, right? Like, this now is sort of broken. So what I'm trying to say is that we have done no error handling at all. So as the last task, if I want to catch errors, where should that be done? In evaluate. That's the only place where errors can be triggered in the whole system. Okay, so we say something like, try to do this evaluation in the exception that you get a syntax error, except, then go ahead and flash the screen, right? And then you can return, right? We're finished. Otherwise, I guess maybe self.text gets the word error, and then we can flash the screen. So let's try this. So 9 plus minus divide by 6. That should now not crash. Now we should generate an error message. Yep, perfect.
Shouldn't the like self-flash and error thing be swapped so that the errors in the except?
Okay, so try to do this. And if we fail, oh yeah, you're right. Then do this. Then I actually don't need that return. Oh yeah, must have been. Okay, plus minus divide times 3 equal error. And see, no error has been triggered. Like, we're still working away. It's still not technically correct because what's now in my display? Error. So what now happens if I hit equal? Well, what kind of error? Because I'm try accepting around a syntax error. Is error bad Python syntax? You have a Python program. It contains one line. It contains the one line error. I run it. What happens? Value error. Yeah. Or name error, name error, name error. If the error is like, it's saying you're asking for me to evaluate error, the variable. It's not defined yet. Right. So we need one more exception. Yes, miss. Yes. Thank you. And then one more exception for name error. And we just pass. Don't do anything. 96 minus 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 2 equal 98. What? Divide by 6. Error. I should hit equal and nothing should happen. Cool. I should hit clear and we're off to the races again. Okay. It's like, so now all really is left is like sort of like reconfiguring this, maybe like giving it better styling. But yeah, like we wrote a calculator app, 50 minutes maybe, and we did so clever, right? Like most of the work was done by this make button. I didn't have to write like 16 different handlers. I wrote one generic button. Most of that genericity was useful, right? Because most of the buttons, all we wanted them to do was take the symbol on the button and add it to the display. For those buttons that had functionality a little bit beyond that, we simply just said, okay, fine, I'll just give it to me and then I'll just configure you afterwards. I'll add to you this extra functionality. If I wanted to change now any of the styling of my buttons, I just go down here and I change it, right? And we will see that like it all immediately propagates, right? All of the styling is still consistent with one change, right? So we have to strive to write code that makes it totally trivial to make these tiny changes so they can propagate, right? It takes a little bit of practice to figure out these abstractions, but the way that I write code is exactly how you see me writing code. When I get to some place like here, what does this button need to do? Well, it needs a command that configures it or evaluates. Okay, just put evaluate in. We'll go write it, right? Top down, right? Just writing and presuming that the tools that we need either exist or will exist once we bring them into being. Okay, so this is calculator. I'm going to give you Uno after we return from the break. It's interesting, but so you have 1 week. I don't want to say off because you certainly don't have 1 week off. You have 1 week with no teaching activities. So please use it to like catch up on your work and read. We now have to start thinking about preparing for the exam. Like we're week 9 of 13. So this is going to creep up, right? So you should start, if you haven't done any of the Shifus, you should start doing some of the Shifus. So your exam is a little bit different than like years previous. So last year we added a full solution question. Last term, we added a full solution question to the exam. So it's 35, it's 30 multiple choice questions, 5 fill in the blank, and then 1 5-mark programming question. 1/3 of the class left that question blank last term. And it was like 9 lines of code that we were asking to write. So this is concerning to me that 1/3 of the class simply just gave up, right? Couldn't write a single line of code. So please do start going through your Shifus. That will be good practice for that type of the exam, though I'm not really worried about people showing. If you've been doing your homework properly without like trying to get the like tutors to do it for you by like working away at them, please debug my code. You should be fine, right? If you know Python, the exam should be pretty straightforward. Are there any questions regarding GUIs or what's next after this? Because when we come back, we'll do Uno, and then we get to do all of the really fun advanced topics. I get to start showing you some computer science. All right. Okay. So enjoy your reading week, and I'll see you all after that reading week. Bye, chat. Please work. Keep up the good work.